Okay, hello, good evening. Uh, Happy Wednesday. Okay, bro, there's only you currently, so let's continue. Okay, today we are going to finish chapter 9, if we can. All right, so today's lesson is rather important. Okay, today is quite important. Oh, hang on. Okay, hello, Jana. Good evening. Just in time. Right, so last week we finished glass and ceramic. Okay, we finished glass and ceramic. As I said, this thing is not very important. Not to say not important, but it's not worth your time because it's only like 1 or 2 questions coming out in objective. So please don't waste time here. Okay, don't waste too much time here. And I did mention what is polymer. Okay, this is very important because today we are going to talk about one of the natural polymer they love asking in exam, which is your natural rubber. Right, so Malaysia is very famous for our rubber, just in case you don't know. So this is our natural rubber. And of course, we have all these synthetic polymers. We learned this last week, which is our plastic. Okay, what is polymerization? What is depolymerization? That's the breaking down of polymer. Right, so today what are we going to learn? Oh yeah, one more thing. What is this addition polymerization? Basically, this is polymerization. Okay, polymerization is when you put everything together. Okay, the full name is actually what we call addition polymerization. This is just not very important. Anyway, so let's talk about rubber today. Okay, this is very important, just like your alloy. Like I said, alloy is for sure coming out in exam. Same goes to rubber. Okay, rubber is the same thing for sure coming out. So please focus on in this chapter please focus on your alloy and rubber. Right, so first of all, rubber, natural, we are talking about natural rubber, not synthetic rubber. This is man-made rubber. We are talking about real rubber. Okay, natural rubber. So natural rubber, they are a natural polymer and they come from this white color fluid called latex. Okay, latex. When you tap the rubber tree, okay, when you tap a rubber tree, you get this white color fluid flowing out. Now that's the latex. All right, so when the latex they dry, they become rubber. Okay, I don't know whether you smell this before. Guys, have you done this experiment in school? Because some of my students, they say they did this in school. All right, so if you have done this in school, if your teacher did let you do this, you will notice something. This latex, they smell like shit. Okay, latex and rubber, I don't know whether you smell it before. They smell like shit. Okay, it's really smelly, that latex smell. Yeah, it smells like bird shit. Okay, so it smells like, okay, when you walk into a tire shop, that smell. Okay, it smells like glove, your rubber glove. Oh my god, it's so bad, and it makes you kind of want to vomit. That feeling, that's the latex. Okay, so your latex, okay, they are from rubber trees. Okay, they're from rubber tree, and then they become natural rubber. So the thing about rubber, why do we love rubber so much? Okay, these are the characteristics. Okay, when you think of rubber, you think of condoms. Okay, why do we still use natural rubber to make condoms? Because natural rubber, they are very strong. So number one, they are elastic. Okay, as you know, condoms, they're elastic. They are so elastic, you can wrap your whole arm with it. Guys, even you wrap your whole arm with condom, it's not going to break. Okay, so if you say, oh, I can, my D is so big, I can break a condom. Yeah, bullshit. Okay, so unless your PP size is as big as your arm, well, then you need to see a doctor. That might be a tumor, my friend. Okay, so first of all, they're elastic. Okay, condoms are very elastic, and of course they are soft. Okay, they are soft and they are not permeable to air. Here's the thing: condoms, they are airtight, just like a balloon. Okay, balloon is made from rubber too, so condoms are made from rubber too, so they're not permeable to air. They are airtight. They are very tight. So Nothing can go through them. Okay, guys, here's the thing. I don't know whether you heard this before. Condoms actually has medical uses. Okay, if you want to protect something, okay, not just your D, okay, not just your PP, but it has some certain uses in medical field as well. Okay, not just for sex. Okay, so very airtight. But the thing is, they cannot withstand heat. Okay, rubber with heat, they will melt. So rubber is very sensitive to heat. Which I'll talk about that later. This is why your windshield wiper, they will spoil. You know your wiper? You know windshield wiper? After like 1 or 2 years, when you switch on the wiper, you kind of see those water streaks on it. It's not so clean already. Okay, when your wiper is new, wow, this thing is 100% clean. Why is that so? It's because of the heat. Okay, because Malaysia is very hot. And of course, it is a good electrical insulator. If you are assembling phones, okay, I don't know whether you know this. If you work in an Apple factory, if you're assembling phone, you need to wear these finger condoms on your finger. Okay, because they are anti-static, they're anti-electric, so you don't short the circuit board, so that you don't spoil the phone. You just put it on your hand. Okay? They sort of look like gloves, but they only go on to your fingers. Okay, so that's all. Okay, these are the characteristics of rubber. Okay, so as you can see, they are very good. Because they are very soft, right? Rubber can be used as sound insulator. Okay, sound insulator or absorber. Okay, what does it mean? If you want a quiet room, you can put rubber on your wall because they will absorb the sound. So it is a very good soundproofing material. Okay, so that's your rubber. Right. So let's talk about acid and alkali. What are their effects on latex? Right. Latex is this white color fluid, right? The one from the tree, right? So acid and alkali, they have their effects on them. So guys, please write this down. Please write this down. Acid is positive, right? And alkali, they are negative. Okay, so again, acid is positive, alkalines, they are negative. Right, so why do we need to know this? Because you see, when you first tap latex, when you zoom into liquid latex, they look like this. This is liquid latex. All right, as you can see, so you might say, so there was this. All right, can you see this sort of look like hair thing? This hair thing in the middle, they are your rubber polymer. Okay, remember what is a polymer? Okay, rubber is a polymer. So your rubber polymer is inside. Okay, and then here's another one. So this is liquid because they did not clump together. Right, listen. When these hair, they join together, your latex will become solid. Okay, let me show you solid latex. Okay, solid latex. Oh my God, what's wrong with this internet? Why is it so slow? Okay, there. This is your solid latex. When they solidify, okay, when they become solid, it just look like this. There, you see, it looks like this. This is the solid latex, right? So when they clump together, they will turn solid. So you see, when they are in liquid form, they will not clump together. Why? Because there's a protein membrane around them. This protein membrane is like a protection so that they don't join together. And to stop them from joining, on these protein membrane, there are negative charges. Can you see this? They are all negative. So since this is also negative, this is also negative, negative, they will repel. It's like you learned this last year, remember last year or last year when you learned electrostatic, remember? Negative, they will push away each other. Okay, positive, they will also push away. So negative are same charges. You see, this is like a girl, this is like a girl, they don't like each other, so they push each other away. So they will remain in liquid. Okay, remain in liquid. This is very important if you're a rubber tapper. Okay, imagine you're working in a rubber estate. Your job is to tap the rubber, okay, tap the latex, and you collect the latex and sell it to factories and bring it to factories. Factories, they don't accept solid latex because solid latex is useless. Okay, they want liquid latex. So when you tap this, they will remain in liquid. So what happens now? What happens now? Okay, so let's look at the first situation. What happens when you add acid? Like I said, acid is positive, right? Acid is positive, right? So a weak acid, guys, ethanoic acid, formic acid, this is your vinegar. Okay, ethanoic acid is your vinegar. So what happens? What happens when you add this acid into latex, right? So this positive charge, they will neutralize the negative charge. Can you see? Just now, liquid latex, I'm full of negative charge. What happens now? When I put positive charge, they will neutralize everything. Okay, they will neutralize everything. So now, this is bad news. You know why? Because now there's no more charge. Now there's no more charge. So just now they can repel each other, right? Now they cannot. Now they cannot. Right? So what happens now? The membrane will be broken. They will crash together. These hair, can you see just now the hair, the rubber polymer? They will crash together and they will coagulate. Please highlight this word. They will coagulate. Okay, that means they will become solid lah. They will coagulate. Okay, in BM we call this menggumpal. Okay, they will coagulate. So now when they coagulate, this thing is worthless unless you're the factory. Okay, let's say you're the factory, you're making glove. This is what you do. You add acid and you coagulate them because you want your rubber, you want your latex to become solid, right? So they can make gloves, right? This is what happens in the factory. In factory, I want this to happen, right? But if you are, you're a rubber tapper, you don't want this to happen because if it happens, then you cannot sell your rubber. Your latex is worthless because now it's just like a coagulated mess. You just have to throw it away, right? So so Jella, I think if you did this experiment, right? So when you add acid, when you stir them, this thing will become solid. This thing will become solid. All right. So as you can see, acid is positive. They will neutralize the negative charge, and then they will coagulate. All right. So guys, not just adding acid, guys. Please write here. Even bacteria can do the same thing. Okay. Even bacteria can do the same thing. Right. If you still remember Form 2, why do we brush our teeth? Because our mouth is acidic at the end of the day. After 1 day of eating, your mouth becomes acidic. Why? Because you have bacteria inside. So same goes, okay, if you don't know this, just think of nasi lemak or any food, right? If you buy nasi lemak in the morning and you put it on your table, after 1 day, can you eat it in the evening? No, you can't, because after like half a day, when you smell your nasi lemak, it kind of smells sour already. You know the food is bad lah. So why is it sour? Because the bacteria starts growing on your food. So now your food is bad, right? So same thing. So bacteria, when they start growing in your latex, bacteria will produce acid. So the same thing will happen. Okay, your latex will coagulate. So this is why when rubber tappers, they go to tap rubber, they have to do it in early morning, like really early. They have to reach rubber estate at like 4 something to 5, and then they have to start tapping. And then before the sun rises around 7, they have to collect all the latex and send it to the factory. Because if they don't do this, okay, the latex, okay, when the sun comes up, the surrounding becomes warm. Okay, the surrounding becomes warm. So now, when surrounding becomes warm, bacteria can start to reproduce. So now, when there's more bacteria, there's more acid, then your latex will coagulate. You guys get what I mean, right? Okay, so this is why you have to tap your rubber and collect everything before the sun rises. So you see, guys, becoming a rubber tapper, it ain't easy. Okay, it was not easy. Okay, it was hard labor. You have to wake up really early. You have to, manually tap every tree. That's a lot of work to do, right? So what I'm trying to say here is, let me summarize everything. Latex, they are negative charge. If you put acid, or when bacteria produce acid, okay, acid is positive, they will neutralize the negative charge. Your rubber polymer will clump together, they will coagulate. Okay, good in a factory setting. Okay, let's say you're trying to make condom, you want your condom to turn solid, right? This is a good thing. But if this thing happens before it reaches the factory, that is bad news, because now your rubber has to be thrown away, right? So how do you stop this? Right, so to stop your, or to say to slow your latex from coagulating, so what do? You add something negative lah. Like I said just now, alkaline is negative, right? So what do? So when you add negative charge to it, when you add alkaline to it, this thing will keep your rubber negative. You can say it will neutralize the positive charge here. So now your rubber polymer, they maintain negative, they won't crash together, no coagulation. So what do you add? You add ammonia. Okay, you add ammonia. This is alkaline. Okay, so this is a weak alkaline, in fact. You can find ammonia in your pee. You can find ammonia in your pee. So to stop your rubber from coagulating, you can actually pee inside your latex. Okay, that's not a lot of ammonia, but it works. Okay, even though it's a bit disgusting. I don't want pee in my rubber, but hey, it works. Okay, it stops your rubber from, from coagulating. So what am I trying to say here is, okay, positive acid will coagulate latex. Negative alkaline, they will make your latex remain solid. P is sterile. Yes, it is. Yes, it is, because of the alkaline. Okay, it is sterile. Right? So anyway, so this is the main point of this chapter, guys. Very important. Very important. This might come out in essay, in objective, or in subjective. Okay, so I think, Jiala, you did this experiment in school, right? Gabriel, I don't know whether you did this or not, or maybe you could be doing this. If you did this experiment in school, right, it's a big sign that this part will come out in experiment. You remember in paper 2, I don't know whether you remember, in paper 2, there's a part, I don't know whether you did this in last exam. In question 10, right, paper 2, right, they will ask you to write a lab report, an experiment report. What does it mean? That means they want you to write hypothesis, aim, problem statement, objective. Still hormones. Wow, so slow. Okay, objectives, variables, procedures, things like that. That question carries 10 marks. Okay, so don't worry, I'll teach you how to write, because in alloy, if you did this experiment, if you have done this experiment, they will ask this in exam also. They ask you to write all these, and they give you 10 marks. Okay, so don't worry. How do you write this? There's a formula you follow. I will teach this formula before your exam in January, I hope. Should be around January lah. Okay, either late of December, shouldn't be late of December lah, because that's Christmas. Okay, usually it's the beginning of January. Okay, I will. Okay, sure. I'll go into that. Okay, I will go into that. Okay, bro, what's your school again? Sorry, I forgot. Okay, I'll go into that. I will teach you how to do that. You follow my formula. It's a for sure 10 mark in the pocket. Oh, Stella Mary is okay. So it is a for sure 10 mark for you. Okay, you have my guarantee if you follow my method lah. Okay, anyway, so let's talk about, okay, since just now we know that rubber is not very good with heat, right? Okay, you see, here's the problem. What are our tires made from? Tires are made from rubber, right? But you see, that's the problem. When tire is running on the road, you have friction. You see, your tire is brushing the ground. Okay, it's frictioning the ground. Okay, frictioning, is that a word? Okay, so when there's a friction with the ground, so now you have a problem. You have a problem. Your tire will get hot, which is a bad thing, you see. You don't want your tire to start melting, will you? Okay, so how do we do? What do? How do we make our rubber stronger? We use something called vulcanization. Okay, please highlight this, very important. Vulcanization is the strengthening of your rubber. To make your rubber stronger, we do vulcanization. Okay, this one also very, very simple. Okay, if you still remember, when we go back to alloy, right? You still remember? Pure metal, they are very soft. You still remember why? Because the atoms, they are easily sliding. Okay, they will slide easily. When you add some foreign atoms to them, now they are, not nicely arranged. Now they are difficult to slide. So it makes alloys harder. So in rubber, we do the same thing. Okay, we do the same thing, but now we don't add, you see, alloy is metal, right? So we add metal. Latex is non-metal, so we add non-metal. So what do? We add sulfur. Okay, we add sulfur. You see, the thing about sulfur is sulfur, when you add sulfur, okay, by the way, this is your rubber polymer. Can you see they are in straight lines? Okay, so same thing, they can easily slide. I think it's mentioned here also. That it, you see, slide over each other. So easy to slide. So when you add sulfur, right, they will build these things. We call it a sulfur crosslink, or some books they call it sulfur bridge. Okay, sulfur bridge, because they look like bridges lah. So okay, remember, you need to learn how to draw them. In exam, they'll ask you to draw. It's two S's. Okay, two S's. So they will form these bridges that holds the thing together. So now can this thing slide? Much more difficult. So now your rubber is stronger and it can stand heat. This thing can tahan more heat lah, so it's stronger lah. So it's harder to melt. So now it's suitable to become tire. Okay, to become tire. Right. This thing, right, vulcanized rubber, right, is actually used everywhere. If you go and buy latex glove nowadays, they are all vulcanized. Okay, because this thing is so much better than natural rubber. Vulcanized rubber is so much better than natural rubber. So this is why, right? Okay, this is why, guys, let's go back to the wiper again. Okay, let's go back to the wiper again. You know your car is wiper, right? Guys, do you know you have to change your wiper every year? I don't know whether your dad does that or whether your mom does that. If they don't, I mean, it's not a problem lah, but it's gonna be a pain in the ass to drive, because okay, especially now it's rainy season, right? If your wiper is not functioning well, if you try to drive at night, it's a really pain to drive if it's raining, because your water streak is around your windshield and then there's reflection of light. It's very hard to see the road. All right. So when you change your wiper, if you go to Shopee, right? Okay, if you buy your wiper from Shopee or you go to Mr. DIY, you see many different prices. You have cheap wipers like 10, 20 ringgit per pair. And then you have branded expensive ones like 50, 60 per pair. And then you have really gila crazy one like 100 something per pair. You might say, sir, why is the difference so big? Because you see, you get what you pay for. Okay, you get what you pay for. If you buy those cheap ones, like 10, 15 bucks ones, okay, those cheap ones, they are usually non-vulcanized rubber. Okay, they are so soft, they are so weak that under the sun for a few months, the thing is gone. Okay, totally gone. But if you buy those branded one like Bosch, okay, they are expensive, 60, 70 bucks, but they are vulcanized rubber, really proper vulcanized rubber. That's why they can last much longer. Okay, and before I proceed, let me tell you, taking your wiper up during a sunny day, that shit doesn't work. Okay, I see people do it all the time. Okay, they park their car under the sun and then they will prop up their wiper looking like idiots. Okay, it's like you thought that they're washing their car. That thing is not going to work. Okay, so I don't know the boomers, they really like doing it. You see those old uncle, old auntie, they go pasar, they park the car, they sure put up their wiper. That shit is not working. Okay, just buy a better wiper. Okay, and then let's go to the 100 something wiper. Okay, let me show you a brand called PIAA. This wiper is like the branded. You see, Guys, 130, I think 130 bucks is like for one. You need a pair, right? So you might say, why the hell is this so expensive? Because they don't even use rubber. They use a new type of rubber. We call it silicone rubber. Guys, have you heard of this? Have you heard of this? You know why silicone rubber? You know why silicone rubber? This thing is even much more stronger than rubber. Okay, and they last much longer. Silicone rubber. This is the thing they put in breast implants lah. Okay, so if you want to make your breast bigger, okay, you go for breast surgery, breast enlargement surgery, they put this in your breast lah. Okay, they last forever. Okay, they last forever. I mean, in terms of wiper, maybe they don't last forever, but 5 years. You see, so you get what you pay for. Yes, they're expensive at first, but you save the hassle of keep buying wipers. Okay, hope you know what I mean. So this is what happens when you vulcanize your rubber. They become stronger, they become tougher, they can stand high temperature, so your rubber can last much longer. Right, so there's a difference here. Okay, I think mine is reverse, yours is okay. Vulcanized rubber should be in this column. Your natural should be here. You see, vulcanized rubber has all the advantage. All right, it is hard, more elastic, difficult to oxidize, does not react with acid and alkali, not permeable to liquid and air, resistant to heat. They have all the advantage. So it's a no-brainer to use vulcanized rubber. Okay, even your cheap latex glove, they are vulcanized too. Okay, here's the thing, guys. Here's the thing. Why would some people use silicone rubber? Because many people, not to say many lah, some they are allergic to latex. Guys, do you know this? Are you allergic to latex? What does it mean? That means if latex touches your skin, your skin doesn't like it, your skin will start having rashes. Okay, so if you're like that, if your skin is allergic to latex, please don't wear a condom. Catwoman, please don't wear a condom. If you have latex allergic, if you wear a condom, your PP is going to swell. It's going to swell. It's going to have rashes on your PP. So be careful. Even condoms, when you buy condoms, they specifically mention on the packaging. Okay, cautious to latex allergy or some shit like that. They mention it on the package. So if you're allergic to latex, so please don't wear condom, or else you're gonna have a bad time. Okay, and you get what I mean, right? So these are, latex. Okay, I think I pretty much finished everything. This is used for tire, rubber gloves, and shoe sole. That's the good thing about vulcanized rubber. Right, this CMA thing, please cross it out. Not coming out for exam, not important. Read it yourself. Okay, so that's all. Right, that's all about rubber, guys. Very easy to study. You see, this is just like alloy. Okay, very straightforward stuff. It is what it is. No twist and turn, nothing. Okay, as long as you study, you should be able to do. Because this is as straightforward as it can get. Okay, the exam question will be, straight and easy. Okay, so what do I mean? Let's go to our question. You will understand. Okay, let's go to our chapter 9 question. Okay, let's go to page 17, shall we? Let's go to question 14. Okay, guys, please go to question 14. So this is page 17. Right, so you see, exactly the same as what we mentioned just now. So this is your rubber molecule. Okay, oh, there they're pointing already. So C is your rubber molecule. And then this membrane, the protecting one, is a protein membrane. Okay, your protein membrane. And then these are the negative charges. Okay, to stop the molecule from bumping into each other so that they don't coagulate. Okay, guys, use the word coagulate. If you use solidify, freezing, no, not accepted. You have to use coagulate. That's the keyword. Right, so as you can see here, what happens when you add acid to it? You see, they even give you a tip already. Acid is positive. So you know what happens lah? This positive charge will neutralize the negative charge, and then they will clump together. They will, coagulate. So explain the action of acid on latex. So first of all, you have to tell me acid is positively charged. Okay, but charge positive. Acid is positively charged. So what do? They will neutralize negative charges on protein membrane. Okay, they will neutralize on this thing, the protein membrane. So now what happens? Your rubber polymer clumps together. So your latex coagulates. Okay, latex menggumpal. So I'm writing 3 points here because it's 3 marks. So you see, guys, it's very straightforward. Can you see? It's a very straightforward question. You already know. Acid is positive. They neutralize the negative. Things clump together, they coagulate. What you studied just now, it comes out exactly like it. There's no K but or whatever. No. As straightforward as it can be. Okay, so next one, they just reverse the questions. Well, what happens when you add alkali? I mean, in exam, they are not so straightforward lah. I mean, do you think they will give you 3 marks, and you get 6? No, of course not. Okay, so what about alkali? So we know that alkali is negatively charged. Wow, it's just the exact opposite. So what happens? They will neutralize. Okay, sorry, they will neutralize acid. Okay, neutralize acid. So rubber polymer does not clump, or you can say they repel each other. Okay, because they remain negative. So your latex remains liquid. Okay, your latex will remain liquid, so there's no clumping. They remain liquid. Okay, so I think some of you, okay, like Jala, I think you did this experiment lah. You add acid, the thing becomes harder. You add alkaline, the thing remains in liquid. In liquid. Okay, I think you did this right. So most schools, they will let you do this. Most schools, you will either do the sorry, brain fart. You will do the alloy experiment, or you will do this latex experiment, or you will do both. Okay, you will do one or both. Hopefully both lah. Hopefully both. All right, so D, give a reason why latex in its natural state does not coagulate immediately. Right, so why does this thing does not coagulate? Because you still have the negative charge. Naturally, they have the negative charge. Okay, so you can say negative charges on protein membrane. Okay, so what do? They repel each other. Okay, they repel each other because negative repels. So E, predict what will happen if latex is left overnight. That is what I just explained just now. So when you leave it overnight, you have bacteria. Okay, so bacteria produce acid in latex. Okay, so what happens now? So latex coagulates. Because you have to say what happened. Okay, latex coagulate is what happened. So what is the reason? Because bacteria produce acid. Okay, guys, don't need to go crazy and explain everything. Oh, because acid is positive, it will neutralize the negative, and then things come together. No. This is only 2 marks, so don't need to go crazy. Okay, so F, take other substances that coagulates latex. Give one inference for answer. Inference means you explain. Okay, so coagulate, you know, any acid will coagulate. So that would be your vinegar. Vinegar is an acid. Okay, so you can say vinegar is an acid or is acidic. So who will prevent coagulation? That will be your alkaline. So in this case, that will be your soap. Because soap solution is an alkaline. Okay, it is an alkaline. Easy, right? You see all the questions that, you know, just keep repeating themselves. So H we skip. Operational definition, I will teach you how to do that next time. But not for now, we skip. Okay, and so not worth, because this will be a very long answer. So it's not worth the 2 marks. Okay, so number 1, circle. Okay, this is number I, sorry. Circle the type of acid used in rubber estate to coagulate. Okay, since they already give you the answer, they want acid, so formic and it's ethanoic. 2, we don't use hydrochloric because this is too strong. Hydrochloric is too strong. Okay, we use hydrochloric in cleaning metals. They are really freaking strong. So alkaline, we use ammonia. Like you said, like I said just now, your pee. You pee into your latex to stop it coagulating. These two, they are soap solution. They are also freaking strong. Okay, so anyway, that's your question. Right, so let's go to the next one. Question 15. I see same question again. So 1, we add acid, formic acid. You know this is going to coagulate. You add ammonia, this is not going to coagulate. You only add distilled water, this will coagulate, but very slowly. Okay, so state the observation. You can say this thing coagulate. Okay, this thing remain liquid. This one is partially coagulate. Okay, that means half coagulate. It's still half liquid, right? So that means this will not coagulate, but there's bacteria in the surrounding, so they will still coagulate slowly. So state the inference. You can explain this yourself lah. Why is it partially coagulate? Because bacteria produce acid. Same as up there. Okay, what can coagulate latex? Okay, your formic acid. Okay, prevents coagulation, ammonia. Okay, what else can replace formic acid and ammonia? You can use ethanoic acid. You can use sodium hydroxide, even though it's too strong, but hey, it's still an alkaline. Okay, so easy, huh? Really easy, huh? So next, let's go to question 15. Okay, so this is 16. Okay, so let's look at question 16. Okay, you see there are 3 boxes here. Okay, there are 3 boxes here. So latex, they add X, they become solid. So what is this? You see, latex is liquid, right? So they turn this thing into solid. This is what? This is coagulation lah. This process is coagulation. So you know that X is definitely an acid, right? It is an acid. So what about process Y? They change from solid to vulcanized. That means strong rubber. So you definitely know this is vulcanization. Okay, vulcanization. We add sulfur to make the rubber stronger. Okay, so you see they put everything together. So don't get confused. This is what we did up there. Okay, this is what we learned just now at the last part there. So name substance X. So you can use anything. You can use formic acid or ethanoic acid. So what's the function? Now this is to coagulate latex. Okay, no need to say neutralize, charge, anything lah. This is only 1 mark. So C, how can solid natural rubber be converted into vulcanized rubber? So how can you convert this? By adding sulfur. Okay, so the process is called vulcanization. You see, it is what it is. Like I said, same as alloy, isn't it? Whatever you study, it's whatever that's coming out. So if your final exam decides to ask this or alloy, it's a win. It's 3 marks for you. So E, explain what happens to the rubber molecule during process Y. So what happens here? What happens to the rubber molecule? They form this thing called we call it a sulfur crosslink. Okay, they form this sulfur crosslink, so they become stronger. Then they ask you to draw already. So the sulfur crosslink, they look like this. Remember, it's 2 S's. 2 S's. Or we call it the sulfur bridge. Same thing. Okay, 2 sulfur. So compare natural rubber and vulcanized rubber. Wow, so many. This is soft. This is hard. This one cannot resist heat. This one can resist heat. This one cannot withstand acid or alkali. This one can. Wow, so many things you can write. Okay, this is less elastic. This is more elastic. Okay, I don't think they will ask. They will not ask like this and give you 8 marks lah. The most they will ask you is 4 in your essay question. Okay, this is coming out in essay. If they do lah, okay, it's 3 marks for you. All right, easy, right, guys? Easy, so it's a very easy question. So let's look at question 17. Question 17. So that's the compare the elasticity of rubber P with rubber Q. So Q, they put it in sulfur. We know that this is vulcanized. We write a V here. This is vulcanized. P is natural. So P should be weaker. So you see, so they put weight onto it. So what happens now? You see, they will return back to 10 cm. Q is more elastic. They manage to return back to 10. But you see, P they only return to 12. That means you see, P is less elastic. Elastic means you can return to shorter lengths. Right? So state the hypothesis that can be made. So you can see P is less elastic than Q. Okay, why is it 2 marks? This should be only giving you 1 mark. So state the variable. What are you not changing? You can say the dimension of rubber. Okay, you can say the length of the rubber, the thickness of the rubber. Okay, things like that. And then manipulated variable. What is the thing that you are changing? That would be your type of rubber. Either you're using natural or you're using vulcanized. So which is more elastic? Of course, that's your Q, your vulcanized. So which are made from natural rubber that has been processed as rubber? Q. That means which uses your vulcanized rubber. There will be your tire and shoe sole. Any hard rubber lah, they will use this. Balloons, I think they still use natural rubber because balloons are not very hard. Okay. Oh, that's it. That's it. All right. So you see, we finished like 10 minutes earlier because this chapter is so damn easy. Right. So we wrap up chapter 9. Any of you have any question about alloy and like I said again, glass and ceramic, please do not focus. You can read it for fun, okay? Because if you think that 1 or 2 question is worth your time, I mean, if memorizing it doesn't take a lot of effort, go do it. Go do it. But if you cannot do it, then don't waste time. Okay, focus on your alloy and rubber first. That's what I always say. Right. So guys, next week we enter November. We will go straight into chapter 10. Okay, chapter 10 is a very easy chapter. Right. So if you have no more question, I think I will stop here. Okay, I know you guys are still having holidays, so I'm just gonna let you go early lah. So I hope to see you next week. I hope to see you again next week. So have a happy Wednesday. I will see you again next week. Right. So take care, everyone. See you next week and ta-ta. Bye-bye.